So I think we can start. Hello again everybody, I am Radu Horoiu, Professional Services Engineer at Infinet Wireless. Thank you very much for joining our webinar. Today's session will be about the Qmxb beamforming base station, which is the newest product of our R5000 range. The agenda includes 5 items. I will start with a short overview of the Qmxb unit, highlighting its main characteristics and specifications. Next, I will briefly explain to you how the beamforming technology works and how does the Qmxb antenna focus its beam towards the CPEs. In the third item, I will do a quick comparison between the Qmxb and the Mmxb units from the performance point of view, indicating the advantages of the Qmxb. Then I will show you some types of applications that can benefit of using the Qmxb units in both point-to-point and point-to-multipoint topologies. In the fifth item, I will list the main benefits of the Qmxb when compared to the Mmxb base station. And in the end, I will make a few additional notes regarding the Qmxb devices. First, a quick glance at the main specifications of the Qmxb. Physically, it looks identical to the Mmxb base station. Currently, it operates only in the 5 GHz frequency band. 3 or 6 GHz versions are not available at the moment. The maximum sector capacity is up to 240 megabits per second, the same as for the Mmxb unit. The maximum transmit power is 25 dBm, so 2 dB less than the Mmxb, but this loss is obviously compensated by the higher antenna gain. Of course, the antenna is the strong point of this device because it is a beam steering antenna. It can electronically steer its 20-degree beam in 15 different positions within the 90 degrees of its maximum beam width, and the gain varies between 21 and 23 dBi. I will go into more details about how the beam steering works a bit later on. The unit weighs 4.4 kilograms, which is about 1 kilogram more than the Mmxb. However, the form factor is the same, so the extra weight is only due to the additional components inside of the smart antenna of the Qmxb. Moving on, I want to explain to you a bit about how the beamforming technology works. And first, in this slide, you can see how the narrow beam is formed. Basically, the narrow beam antenna is comprised of several antenna elements which are connected to a single transmitter or receiver. If the power is fed to all elements evenly, using the same amplitude and phase for the signals, the waves will combine to form a narrower beam in a fixed direction. Thus, the elements act like a single antenna with a higher gain. And more antenna elements are used, the narrower the beam will become, and also the gain will be higher. Now, if the power is fed unevenly to the antenna elements by adjusting some input signal parameters like delay and amplitude, we get control over the antenna beam and the direction of the beam. This technique is called adaptive beamforming or beam steering, and it allows for a better focusing of the signal energy towards individual CPEs, thus improving the link performance. Obviously, the next question that rises is how does the Qmxb pick the right beam for each CPE? Well, the answer is that the CPEs themselves tell the Qmxb base station which beam they can hear better. Then the Qmxb learns which beam to use for every time slot. Of course, if the link conditions change later on and the CPE detects that the reception for the current beam becomes poor, it can ask the Qmxb to change its beam direction at any time. Next, we have a quick comparison between the Qmxb and the Mmxb that shows the main performance advantages of the Qmxb, especially for point-to-multipoint topologies. In this picture, you can see that the first major advantage is the 6 dB increase in the link budget. This means that the CPEs which operate in near line of sight conditions will experience a much higher bitrate. Also, the range of the sector is greatly increased by up to 50%, meaning that by using the Qmxb you can connect to more distant CPEs. Here we have a case study that shows more clearly how much you can improve the bitrate of each CPE by using the Qmxb instead of the Mmxb. The comparison test was done at Flex LLC in Russia, and the network was comprised of 1 base station and 7 CPEs installed at distances ranging from 300 meters to 17 kilometers from the base station. First, these are the reported bitrate figures for the Mmxb setup at all the different distances. And you can see that in case of CPE 4, which operates in near line of sight conditions, and CPE 7, which is located far away from the base station, the bitrate is very low at 13 and 26 megabits per second respectively. And with the Qmxb, on the other hand, the reported bitrates are much higher. The increase is dramatic in case of the two CPEs that I mentioned earlier. For CPE 4, we see a 500% bitrate increase from 13 to 78 megabits per second. And for CPE 7, there is a 10% increase from 26 to 78 megabits per second. The other CPEs also have significant bitrate improvements between 10% and 125%. And also, it is very important to mention that the number of CPEs that can achieve the highest modulation of QAM64 has increased from 4 with the Mmxb to 7, so all the CPEs with the Qmxb in this particular example. Although the Qmxb has been primarily designed as a base station to be used mainly in point-to-multipoint topologies, it can work as a point-to-point device as well, and it offers a very important benefit over the traditional point-to-point devices in the fact that the antenna alignment is very easy to perform. Only an approximate alignment needs to be performed by the technicians, and after that the beams will be automatically aligned more precisely by the devices themselves. This makes the Qmxb unit highly suitable for nomadic and mobile scenarios, or for applications that involve installing the devices in unstable locations like over the water, for example. In the next slides, we have a few pictures that show some applications for which the Qmxb is more suitable to use than other point-to-point devices. These scenarios include temporary installations that must provide wireless connectivity for public events, construction sites, sports events, concerts, backhaul for temporary LTE stations, and other situations in which a precise antenna alignment might be difficult to perform or maintain throughout the whole period of operation. The energy and natural resources sectors and other highly specialized industries can also benefit of the Qmxb advantages when deploying point-to-point links. The applications in these industries often involve installing wireless network devices in remote locations and then moving them from one place to another. Also, in most cases, the pole on which the devices must be installed cannot be higher than 5 or 10 meters, and this leads to situations when there is no clear line of sight and the antennas cannot be aligned very precisely. These are exactly the cases in which the Qmxb can really make a big difference, offering a major performance improvement, as we saw earlier in the Flex LLC case study. As mentioned earlier, another application that can greatly benefit of the Qmxb's ability to work better in challenging conditions is over-the-water links. when the units must be installed on boats or platforms located on large lakes or in the sea, the precise alignment of the antennas cannot be performed because of the constant movement of the floating platform. Using the Qmxb in these cases will obviously increase performance in comparison with the non-beam steering point-to-point devices. When we talk about ship-to-shore projects, it is important to mention that a ship at sea can move in 6 different directions, as you can see in the picture. Only 2 of these movements can be compensated by the Qmxb: the sway, which is the horizontal drift, and the yaw, which is the rotation around the ship's own axis. The movement in other directions can be compensated only by deploying a special mounting device called gyro platform, which you can see in the right side of the slide. By using a set of motors, it can change the orientation of the antenna in all directions in order to find the best signal level. If you are interested in this kind of device for your projects, you can contact us at pre-sales at infinitewireless.com for more information. A good example of a ship-to-shore project which was implemented using Qmxb units is the Red Funnel ferries in the UK. Red Funnel wanted uninterrupted connectivity for all its ferries running between Southampton and East and West Coasts on the Isle of Wight. The Qmxbs were installed on the shore, while on the ferries normal CPEs were used. As a result of the deployment, Red Funnel is now able to offer free Wi-Fi to all its passengers as part of their customer service. Also, the location status for all ferries is available online, as you can see in this screenshot. So if you follow the link on the screen, you can see in real time the location of each ferry in this area. In the picture we have one of the ferries, and if we zoom in a bit, you can see where the CPEs are installed. There are a lot of CPEs on this particular ship. The beam steering ability of the Qmxb can be extremely useful in case of the mobility projects as well. In these situations, the rapid vehicle movement and the terrain irregularities can sometimes lead to misalignment, severely degrading the overall performance. As mentioned earlier, the Qmxb adds up to 6 dB to the link budget while constantly adjusting the alignment of the antenna beams. This means that the bitrate increase when compared to Mmxb can be of up to 300% in some situations, as you can see in the example presented in this picture. Moving on, I want to round up the main benefits of the Qmxb, especially when compared to the Mmxb base station that does not have the smart beam steering antenna. And the first benefit that I want to point out is that with the Qmxb, less power is required in the uplink direction. So because the Qmxb antenna has a higher gain and the beam is narrower, the CPE can lower its transmit power and the RSSI of the base station will remain the same as with an Mmxb. Another benefit of the higher gain Qmxb antenna is that the CINR at the CPE reception will also be higher, thus allowing the CPE to operate at a higher bitrate. Because the beam of the Qmxb antenna is narrower and the radiation energy is more focused towards the CPEs, the overall interference generated by the base station is much lower. Also, the Qmxb is more resilient to interference generated by other devices. This is very important, especially in dense urban environments where there are a lot of wireless devices operating in the non-licensed bands. The achievable sector capacity is higher with the Qmxb because CPEs can operate at higher modulation levels. Also, the performance at the edges of the sector is greatly improved. The Qmxb comes with the TDMA firmware out of the box, so it allows you to sync the units using the external GPS module and deploy an ABAB frequency reuse system. This can be very useful in situations when you only have a small number of clear frequency channels to work with. The Mmxb can also operate using TDMA, but it does not come as standard. The upgrade to TDMA must be performed manually on the Mmxb units. The network planning and design are obviously simplified with the Qmxb because the antennas are much easier to align and the interference between the units is lower. And last but not least, the link operation of the Qmxb devices is much more stable, especially in challenging conditions when there is no clear line of sight between the units. In the end, I want to make a few additional notes regarding the Qmxb that I think are important to be mentioned too. First, the Qmxb is TDMA based only, so you cannot use the polling firmware that is standard with the other R5000 units. The web GUI and CLI on the other hand are the same as on a standard R5000 device because the OneFlex operating system is the same. The maximum capacity of 200 megabits per second is the same as for the Mmxb. As mentioned in the previous slide, the Qmxb is compatible with the external GPS module called Auxiliary Audio Sync, allowing you to synchronize the transmission and reception of your units and thus reduce interference between them. The Qmxb unit is available in the Point-to-Multipoint section of our InfiPlanner online tool. The additional delay introduced by the beam steering operation is insignificant, about 0.001% compared to non-beamforming devices, so it can be ignored without problems. And there is no instant DFS option, unfortunately, for the Qmxb at the moment. Please note that the Infinet Wireless pre-sales team offers pre-project estimation services for free. So you can send us your scenario to presales@infinitewireless.com and we will give you our recommendations, including the most suitable equipment for your project and link planning estimations. So please don't hesitate to contact us at any time. So this brings us to the end of today's presentation. Please feel free to write down your questions in the chat sections. I see that you have written a few questions already. So me and Vasily will help with all the information. We will answer all your questions. Thank you. Yeah, so the question about the TDMA firmware has been answered in the presentation. About multi-user MIMO, no, the Qmxb doesn't have. We will have multi-user MIMO in the future, in the near future maybe, but I don't have information currently about the release of the multi-user MIMO device yet. Oh, question about an XG device that is not quite related but to this presentation, but on any of our devices, including the XG, you have the spectrum analyzer. You can use it to measure the interference on all the spectrum, on all the supported spectrum of the unit, so you can use that to see the interference on the XG. Next question is is the Qmxb available on the 3 GHz band? No, at the moment we only have Qmxb in 5 GHz. Next question, are we getting the slides? Yes. Along with the thank you letter, you will receive the recording of the session and the presentation as well. Next, a practical question, practical test on field, and I noticed regarding the SNR that is half from transmit side, for instance 45-26, and normally should be 45-45 more or less, even though the modulation is 117 by 117. There could be a lot of reasons for this problem, so I'm not sure right now. It could have to do with the link conditions in general. It could be interference, so I'm not sure. This should be further investigated, maybe by the support team. If you notice that this doesn't improve with time, if it's a constant problem, you can raise a ticket to our support team and they will help you with this particular issue. Again, a question about the slides. Yes, you will receive them. Next question, when will it be available in 3.5 GHz? I don't know. There is no official information at the moment about 3 GHz Qmxb. The Qmxb, yes, and other Infinet point-to-point devices can be used on the same tower, no problem. You just have to make sure you have enough separation between them if they operate on similar frequencies, so you don't have interference. How many elements does this antenna have? I don't have this information at the moment, but I think it's 4 elements. I'm not for sure, I have to check, but most probably 4 elements, because the Mmxb antenna also has 4 elements, and this is the same size. The Qmxb antenna is the same size, so most probably it has 4 antenna elements inside. Okay, so again I see the question about why there is this difference in bitrate between uplink and downlink. It shouldn't be like this. So in a typical field scenario, this shouldn't happen. I'm not sure why. It doesn't have to do with the equipment itself. It has to do with the situation in which it was installed. So maybe there is some interference only on the side of one of the equipment. So so if you have a point-to-point link, one of the devices could be installed in an area where you have no interference, and it could hear very well the signal from the other unit, but in the other peer you could have some interference, and it doesn't hear as well the signal from the other unit. So this might be a reason for this difference in bitrate between the uplink and the downlink. Next question, for the link budget of point-to-multipoint links is calculated to each link. Yes, with link planner. I think you are asking about Infi planner, and in case of point-to-multipoint links in Infi planner, the calculations, from what I know, I don't know if a recent update has been made, but a few weeks or months ago you didn't get the calculations for the whole network or sector, let's say. So if you had a base station and several CPEs, 10 CPEs for example, connected to it, you would get the results, the individual results for each link. So between the base station and each CPE, you would see the maximum capacity of that link by ignoring all the other CPEs in the sector. So the Infi planner doesn't take all the CPEs into account when it calculates the throughput results for the links. So you should keep this in mind, that is the maximum capacity that you can achieve for that link when you don't have other devices connected to the base station. Next question, will it be available with IDFS? Maybe. We had very many requests about Qmxb with IDFS, so I think it will be done, but we don't have a clear date at which it will be launched at this moment. Next question, yes, is it compatible with our existing CPEs? Yes, the Qmxb works with the existing CPEs, no problem. There are no new CPEs for the Qmxb. Next question, just to be sure I understand correctly, when you use the name bitrate, you mean the theoretical one or the real usable throughput? To clear this, the bitrate is the reported, the bitrate which I was referring to in this presentation is the reported bitrate of the unit. So it's not the real throughput, it's the reported bitrate, which indicates the modulation at which the unit operates. So it's not real throughput. It's the reported bitrate of the unit. Again, a question about compatibility with CPEs. Yes, the Qmxb is compatible. Of course, the CPEs, yes, they have to be upgraded to TDMA. They have to have the same firmware as the Qmxb in order to make a link with them. Okay, again, a question about the link budget of point-to-multipoint links. No, in case of mobility, we don't have support for mobility yet in the Infi planner, because it's really difficult to implement, because you have to take into account a lot of factors, where the units will move around the sector. So at the moment, no, we don't have any tool that can estimate links and do calculations for the links in mobility scenarios. Next question, brief description of how the TDMA functions. Yeah, so basically the TDMA works by time division, as the name suggests, and yeah, you have fixed, as opposed to the marker access firmware that is standard with other R5000 units. The TDMA is based on fixed time slots, and each CPE receives a time slot during which it can receive and transmit data. And the TDMA has a fixed overhead, so the max bitrate will depend on how many CPEs you have in your network. So we have a formula to calculate this. I don't have it in front of me at this moment, but I can send it to you, how to calculate the effective bitrate of your network depending on how many CPEs you have in a sector. So you won't have 24, if you have 10 CPEs in a sector, you won't have 24 megabits per second for each CPE. It will be a bit less than that, but I cannot tell you right now exactly how much you will have on each CPE. So it can be somewhere around 18-20 megabits per second. There is a formula to calculate that. I will send it to you if you are interested in finding out exactly how many megabits per second you can expect to get in this particular scenario of yours. Yeah, so if you wait a few seconds, I can try to get this formula right now to send it to you. And yeah, another question. Yeah, the 20 degrees is horizontal beam width for the antenna. As you saw, actually, I will go to the fifth slide, I think sixth slide again, to show you, because I have all the information here. Yeah. So yeah, as you can see in this slide, the beam width is 20 degrees by 8. So 20 is horizontal and 8 is vertical. You have here both the widths in horizontal and vertical beam width as well. So it's 90 degrees, but these 90 degrees are the whole beam width, and the narrower beam is only 20 degrees, and that is that 20 degrees is steered across these 90 degrees of the antenna. The next question, the explanation for synchronization to reduce high interference. The synchronization helps you when you have 4 base stations. Let's say if you have 4 base stations on this mounted back to back, 4 90 degrees sectors, 2 of them 2 by 2 mounted back to back, and you want to use only 2 frequency channels on those base stations. You can use basically for back-to-back sectors, you can use the same frequency if they are the synchronization makes them send and receive data at the same time. So if they use TDMA with fixed time slot, they will send and receive data at the same time. So there will be no situations when a unit transmits and another one receives at the same time, and then you will have interference. So basically, this is how synchronization helps you reduce interference. It makes all the devices that are synchronized send and receive data at the same time. And to apply the synchronization, you must connect, you must purchase the external GPS device, the auxiliary ODU sync, and the H08 units, so the base stations and the Infilink Pro units, have a special port that can connect to the external GPS device. The device can synchronize up to 7 different units installed in the same place. It connects to a cable, with a cable to the units, and it offers GPS synchronization. Okay, so about the throughput in a sector, I can't find this formula right now. Actually, it was an estimation that we have done in the lab in the past, so I cannot tell you a clear formula. I just I can give you just the parameters that influence throughput, like overhead and so on. So if you have many CPEs, obviously the overhead will be higher, especially in case of TDMA, and this is why TDMA is not recommended with bandwidths of small bandwidths of 5 or 10 megabits per second, because then you will have you will lose a lot of throughput by the overheads, and basically you should expect less than the theoretical 24 megabits per second in this example. If you have 240, that's the theoretical throughput that you can achieve with only one CPE in the sector. So if you have 10 CPEs, you will have more overhead, because the base station must must introduce some guard intervals when communicating with more CPEs, and you will lose some usable throughput by that overhead. So it will be less, but it has to be tested. I cannot give you an clear formula because it really depends very much on your situations, on the field situations. It's not something extremely stable or that you can calculate and be valid for all situations. So basically with TDMA, I recommend that you use at least 20 megahertz bandwidth, so 20 or 40 megahertz, and also you can apply synchronization as well, and in order to reduce interference. So you have to reduce interference to a minimum in order to maximize the available throughput, the real throughput for your devices. And of course, the more CPEs you use, the smaller the lower the real throughput will be. Okay, next question. The feature to activate the synchronization is a solution to reduce the frequency and optimize the frequency plan in our networks. Yes, if you use TDMA and synchronization, you can optimize your frequency plan. So obviously you can use a tighter frequency reuse scheme with TDMA and synchronization, and yeah, it helps you reduce the number of channels that you need for your network. For XG devices, actually the XG devices are easier to synchronize because they don't need the synchronization unit. They have an internal GPS module, and you only need an external GPS antenna. So you just need a normal GPS antenna. You don't have to purchase the module, the GPS module. You just need external antenna connected to the XG, and it will synchronize through that antenna because it has an internal GPS module. Yeah, so another question about the GPS antenna for the XG. Yeah, there is a specific GPS antenna. You can find it in the accessories section on our website. Okay, so going back to the discussion about TDMA, and yeah, so if you had only one CPE transmitting, and yeah, I don't know if you would get 24 megabits per second for that CPE. It has to be tested. It could be less. Actually, for TDMA, recently our TDMA firmware has been upgraded, and now it can use, in some situations, if you don't need the fixed time slot, and you select in the web interface, you have the option to select automatic frame size. The TDMA can use the concept of sub slots, and it borrows some of the functionality from the polling software, but the TDMA frame is still divided into uplink part and downlink part, but in the uplink part and downlink part there can be more than one slot, so you can have more CPEs transmitting during the same time slot. And also, if some CPEs are idle and only one has to transmit, it can receive more time slots than the others, and it can get much more than those 24 megabits per second. So if you have 10 CPEs and 9 of them are idle, the active CPE could get as much as it needs, up to, I don't know, maybe even more than 100 megabits per second or something like that. So it really depends on your scenario. In theory, I think if you have 10 CPEs in a 240 megabits per second sector, you can get up to 20 or something like that, maybe, if you have ideal conditions for each CPE. But if you use the automatic time frame, the automatic size time frame, maybe you can get more than that for each CPE, according to how much traffic is on each CPE in that situation. Yeah, I'm glad I could explain the TDMA a bit. Yeah, it's quite complicated how these subslots work, but I can give you a link from our documentation to read more over there. Just a second. Yeah, so just a second. Yeah, I will leave this link here. For you to read more about the TDMA subslots if you are interested in this topic. Yeah, you're welcome. And I think you can use, yeah, it's just simple antenna. I don't know, actually I'll look right now at a unit, at an XG unit. I think it has a normal port, and you can connect any antenna with an N-type port. Yeah, so I have an XG here, and this, I don't know if you can see very well. This is the GPS antenna port. It's a simple N-type port, and you can use any antenna, any GPS antenna. You don't need to buy it necessarily from Infinet. Of course, we recommend you to buy from us, but if you have the antenna from somewhere else, it's fine. It works. You can use it. Okay, another question about the capacity of Qmxb. No, the maximum capacity of 240 megabits per second of the Qmxb is shared between all the subscribers. So each subscriber will get a fraction of these 240 megabits per second. It's not per subscriber, it's the shared capacity for all the sector. Okay, so I see that there are no more questions. thank you very much for joining. It was an interesting session, lots of questions. It's been really great to talk to you, and I hope to see you again during our next webinar, which will be next month in March. Another question about the MMX BTS. It's 240 megabits per second, just the same as for the MMXB. Okay, so any more questions, guys? And for the CPEs, it depends on what kind of CPEs do you use. For the CPEs, you can opt for license limited capacity. You can opt for 8 megabits per second, only 8, 50, or the maximum of 180. So CPEs, the normal CPEs have 180 megabits per second, and you can also connect Infilink 2x2 Pro units as CPEs to a base station. If you need more capacity, you can use a Pro device that has up to 280, in theory, 280 megabits per second. So if you connect it to a base station, obviously it will be 240 maximum theoretical capacity for that link, because it will be limited by the base station capacity. Yes, yeah, the CPEs of course have fast Ethernet interfaces, yeah, but they have 2 fast Ethernet ports. So if you need more than 100 megabits per second, you can use link aggregation to get more than 100 on a link. Okay, so thank you very much again, guys. It's really been an interesting session, and we will see each other again next month in March. So have a great day. Goodbye, and thank you again.